In this video, I want to focus on a slightly faster way to convert from base 10 to our computer bases, so base 2, base 8, base 16. And the way we can do this a little faster is to do it by repeated division. This works a lot better with base 2 than the others, but it works the same for all of them. So let's just go through an example of each. Two examples of base 2 and then just one example of each of the others. So if I want to take 10, write in black here, and I want to convert it to base 2, what I'm going to do is divide it by 2. Now, I wrote that upside down on purpose. I'm going to keep dividing by 2, dividing the quotients by 2 over and over again. And the key here to focus on is the remainder. So now I divide 10 by 2, I get a remainder of 0. Okay? So now I'm going to take just this 5 and divide it by 2. 2 goes into 5 twice, with a remainder of 1. Okay, if you missed that, pause for a second or replay it and see, oh yes, 5 divided by 2 is 2 with a remainder of 1, and I'm just writing it upside down. Now, I'm going to take 2 and divide it by 2, which will give me 1 with a remainder of 0. Okay, again, I'm not doing anything with the remainders, I'm just doing this with the division. Now I'm going to take 1 and divide it by 2. I'm going to get 0 with a remainder of 1. And at this point I can stop, because if I keep dividing, I'm going to keep getting zeros. So what I do to recover my number then is I take these in the reverse order that I got them. At the beginning of my number is 1, and then 0, and then 1, and then 0, base 2, and this is the number 10. And if you think about your base 2, that's 1, 8, 1, 2. Of course, that's base 10. Okay, let's do another one. Let's convert 601 to a base 2 numeral. So I'm going to take 601 and divide it by 2. Well, I'll get 3, 0, 0 with a remainder of 1. That 1 is going to end up in my ones place. I'm going to take 300 and divide it by 2. I will get 150 with a remainder of 0. That 0 is going to end up in my 2's place. 150 divided by 2 is 75 with a remainder of 0. That 0 is going to end up in my 2 squared, or my 4's place. 75 divided by 2 is going to be 3, leave me with 15, so 7, remainder 1. That 1's going to end up in my 2, 4, 8 place. Divide this by 2, it's going to be 1, 8, remainder 1. 18 divided by 2 is 9, remainder 0. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And finally, 1 divided by 2 is 0, remainder 1. So starting at the bottom here, this number is 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, base 2. And is that 602? Well, let's see. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, hold on. Sorry, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Forgot about 1. That's always my biggest downfall when I'm trying to change from binary to decimal. And sometimes I just forget that 1. 512 plus 64 plus 16 plus 8 plus 1 is 601. So we got it correct. Okay, let's do a couple, or do one each of these others. I want to convert 2500 to base 8. I can do this same process. 2,500 divided by 8 is 312, with a remainder of 4. Okay, now I take 312 and divide it by 8. That gives me 39 with a remainder of 0. Divide this by 8. That's going to give me 4 with a remainder of 7. Divide this by 8. That's going to give me 0 with a remainder of 4. Starting at the bottom, this is 4, 7, 0, 4, base 8. Let's do just one more. Let's do a base 16 one. I would convert 42,273 to base 16. So I take 4,273 divided by 16. I get 267 with a remainder of 1. So now I'm going to take 267 divided by 16. That gives me 16 with a remainder of 11. Divide 16 by 16, that gives me 1 with a remainder of 0. Divide 1 by 16, that gives me 0 with a remainder of 1. So this is 1, 0, A is 10, so B is 11, 1, base 16. And I can check 1 times 16 plus 0 is 16, times 16 is 256, plus 11 is 267, times 16 is 4,272, plus 1 is 4,273. Yep, that is the correct number.